So let me then start, and perhaps at first I have to explain why we decided this time to talk about security. So 2 years ago, we had a conference dedicated to cloud topics. It was new and shiny at that time. A year ago, we talked about DevOps concepts, and this time we wanted to talk about security. And why? Well, probably I don't have to explain it to you because you are here and you think the security is very important. But still, we think that security is very important, and if we think it's in different levels, so it's why security? Well, security is important. So in personal level, my credit card, my privacy, the privacy perhaps is even more important than credit card. Well, it depends on the amounts of on credit card, of course, but still, it's on my personal level, it's very important. So in company level, companies face, are we ready for DDoS attacks or embarrassing announcements on our website or not? How are we going to deal with that? Very important. Our money, intellectual property. So obviously, to keep it inside the company, very, very important. And also in state level, espionage, mission critical infrastructure. And if we just for a moment think about victims and perhaps most famous ones, then into my head, I think about last year's November, December, big US retailer Target attack, when they lost, well, at first it was like they said that they lost something like 30 million credit card numbers. Then it was like 70 million, and now they talk about 100 million credit card numbers. And compared to the population in US, it's quite a big number. Very big, and got lots of, very painful reaction from press. Now, perhaps from the other side of the world, Saudi Aramco, the big oil producer. A few years ago, they had a little incident. They lost 30,000 PCs. Well, not PCs, but information on the PC, because some bad guys locked that information and replaced it by burning American flag in one day. Well, Saudi Aramco is a big organization, obviously, but the loss of 30,000 computers probably impacted them a bit as well. So it's quite important to make sure that everything is secure. And also what we see is that the way how the bad guys attack have changed. It's not always that I come and destroy your website, but rather I sneak in, try to be hidden there and get out as much information as possible. Well, and the country level, state level, government level, the intelligence is getting more and more important in today's world. And from where to get that intelligence? From other people's PCs, of course. So you get all the documents are there, you go there and look. So the cyberspace is a very good place just to go and get more information. So we want to make sure that our PCs and our stuff is protected from our friends. And not friends. And mission critical infrastructure. So this gets us to the cyber war, right? And there is a big debate about that. Is it really possible to attack from your PC the power plant? We have at least one case when this kind of setup was successful, and this is a story about Iran. And they had little problems with a nuclear reactor there. And this is a famous story about Stuxnet, which is malware, and experts call it Rolls-Royce of the malware, because it's custom made only for that particular control system and software. And so it's almost invisible, very hard to detect, very hard to understand. It actually works before it starts to work. So almost invisible. So what the Stuxnet did, they had some centrifuges, but had to really work there, and the control unit. And the control unit was deceived by that malware. Malware said to the control unit that speed of the centrifuges is too low, spinning at too low speeds. So the control unit sent speed up, speed up, speed up, and they started to speed faster. But in fact, they already spin at maximum speed. So they get worn out and broke. So replaced them, broke again, replaced, broke again. And then it appeared that it was kind of some bad guys, or good guys, whatever, who actually did it. But that was something where really the cyber attack was successful against mission-critical infrastructure. So basically it can happen. So we have to really protect also our mission-critical systems and our SCADA system, others, what we have here as well. The espionage is interesting because just the day before yesterday, the Verizon big cybersecurity report released. And they analyzed over the year like thousands of companies and thousands of incidents. And they said that one of the change from the last year, or the big change what they saw, was espionage. They said 3 times increase of the cases. So that's kind of looks to be a good area. So I'm very proud of the next slide. I integrated by myself, right? It's so beautiful. Why security? Why security? Because it's important for me, for my company, and for my country. So it can't be, so beautiful, isn't it, right? But now, what we're going to do now, we go to the IT department. So this is good, PowerPoint is good, we all know it's important, but now we go to IT department. Look what's happening there. And IT department, we have seen something like that. I mean, this is a quote from the customer, and they're saying that, I can get virtual servers in 5 minutes, but then it takes 2 weeks to open ports firewall to access that virtual machine. So I can't do anything anyway. So it takes time. So it's kind of a speed versus security question. And this is kind of in practice what we have seen. And I'm not really sure that security will win, or at least always. Perhaps in some industries like banking, they are very strict on that, but not everywhere perhaps. So the speed is kind of important for the business. And this is kind of operationally really hard to say that, okay, let's do it this way. And we intend to do shortcuts, right? And I give even another example, or move even further from there. If I would ask like this from the business perspective now, has any company bankrupted because of the cyber attack? Somebody knows 1, 2? Yeah, well, we got a couple, right? So, but I believe that there are thousands of companies who bankrupted because of competition in this morning. So a bit of change of magnitude, so difference of magnitude, right? So is it important then? Or? Well, and we go to that, the speed versus security question. And I think the speed has some fundamental importance for the business, for the competition. And just to show that, I'm taking a lean startup case. This is a methodology of the movement of the business thinking, which has made its way now to the mainstream business thinking, to the Harvard Business Review and other magazines and so on. And what it tells, because speed in the startup world is very important. You have to be really agile there, yeah? And that's why I take the lean startup model and world of startups. That thinking is based on the assumption that startups do not fail because they do bad products, but they do product that nobody really needs, strange things. Maybe they have a good idea, but they package in the wrong way or do it something wrong. And the question is then that how to get from the plan A, which looked to be perfect plan, to the plan which actually works. We had a discussion with Frank yesterday, and he asked to remember how the YouTube and Flickr were born. And they weren't really meant to work like they work today. They were very, very different companies. They had to change and change quickly. So the question how to learn is very important. The speed of the change is very important. And I've got a couple of quotes from the famous people who understand that it's not always that you have a perfect plan and you're going to do that. And Napoleon is one of those, telling that you need to control a chaos, your own and your enemy chaos. So how to manage that chaos, how to understand what is good, and how to change that according to the circumstances. I've got another quote as well from the modern thinker, the person who is more kind of worked in the kind of tactical area, but managed to put kind of the same idea that you need to change quickly and rethink quickly in a shorter and elegant form so we get the idea better. So this is everybody has a plan until they get punched into the mouth. Mike Tyson. That means that, for me, that if you happen to be in the boxing ring, you might want to think very fast, or sometimes act before you actually do something. But you have to adapt very quickly. That's why the speed is so important, right? And scientists have kind of looked to the systems, to the complex system, to the simple systems, and brought this kind of framework to understand what kind of systems are there in the world. So we see that the market is kind of complex. We don't exactly know what's going to happen. There are some simple systems, like a bicycle. When bicycle is broke, something is wrong with bicycle, then it's a simple system, so we can look to the bicycle, see that there is something wrong, think about and respond to fix it, right? When the system is a bit more complicated, then we perhaps have to run some diagnosis, do some analysis. But it's sensing, looking to it, thinking, or analyzing, and then doing. But this is a world what we really control. The other side, the left side, is the world we don't really control. So we are not really sure what's going to happen if we do something. Or moreover, actually, fundamentally, we may not be able to get any good understanding before we try, before we test. And that's why the action list is a bit different there. It's probe, sense, respond. So you have to go and try to do something, and then you get information, does it really work or not? And that's what happens with the startups. They have to go there, try, test, and see if the idea works, and then change. And what we see is that if this kind of thinking and way of thinking is coming more to the other companies as well. Perhaps there are some utility companies who can take it a bit more easy and relaxed, but many companies have to take the same kind of attitude. And if your company has to do something with the IT, then IT has to respond as well. So the speed is enormously important. All right, so, well, again, that market, just coming from the business side, I brought that idea from Stefan Garelli, Swiss economist and IMD professor, and he kind of explained why the market can be kind of unpredictable. You don't know that. You do something, think it's a good thing, but it may not be a good thing. And he said that behavior and consumers actually have changed. Well, it's need versus want economy. So the need is kind of in the emerging markets. Well, people need the first bicycle, they need the first laptop, and so on, right? In the developed countries, developed economies, it's more like want business, it's replacement business. I already have my bicycle, yeah, but I may want a new one, right? I already have PC, but I may want Mac, right? So I may want. So there is something which is like mystical, magical there. It's not only price performance, there is something else. But if there is something mystical, then it is not, about the Excel that I do a perfect plan. You have to go and try. It's like entertainment business. The same album from the same band may not be successful because it's, something is different there, or people don't they get it. So you have to go, you have to try. If it doesn't work, you have to change. The speed is absolutely crucial for the business. So it's kind of a probe, sense, act, and that comes more and more to the business, and this is why we have that agile development process and all the related topics. So we need to change, and who will survive? Fast adapters. So speed is really, really critical. So let me come back now to the question that has any company bankrupted because of the cyber attacks? Yes, we got 5 in this room, right? And probably somebody has another 5. So kind of 10, but there is so many companies who, didn't survive because of competition, right? So it's a question, but the speed is absolutely important. Now, my question is then, should we take or ask the question in this way, speed versus security? Can we have them somehow together? Well, no, right? The security guys, the 15 guys we know them, they stopping our business and they saying no all the time, and then we have to wait and we know how it goes, right? But there is light in the tunnel, and we have to look to some areas which are perhaps close to the IT or in the IT when this kind of problem has been solved. And last year we talked about DevOps concept, and they had a question about speed, agile development, and reliability of system, business continuity, and so on. And they somehow solved that problem. So we can look at if it somehow works for us as well in security. So DevOps at Netflix, what they said already 5 years ago, 2009, that they can do 10 deploys per day. Flickr and Facebooks and others as well. So they can do, they are very, very fast, right? But at the same time, they have reliable IT. They used to have a couple of years ago, they had Amazon downtime, and the Netflix run all the services from different clouds, including Amazon. They weren't really touched about that. I mean, these services worked because they were prepared for the downtime of any cloud provider. Because they had this little thing, what we also discussed last year, Chaos Monkey. This little piece of the program, a code, and it has one task. Switch on randomly services in production system. Random services, random time, production system. Yeah? Runs there all the time. So last time, one of the presenters said that they have that kind of service in their IT department as well, because things happen randomly somehow, and some services are switched off. Well, but the thing is that they prepared the applications they have, they are designed in the way that they can handle disruption. They can restore, they can do whatever they can do, but it actually works. So it is possible to have a reliable IT, it is possible to have the speed at the same time. Well, and what are the principles of the DevOps? Very easy ones. So number one, culture, removing barriers between the development and operations. Of course, a bit easier to say than to do that, but nothing really magical. Continuous delivery, configuration, almost religious configuration control. So everything has to be like it has to be. Standardization and automation. So nothing really very complicated. So easy principles, and you can do miracles with those principles. So why we don't do then those miracles? Why we have that problem, and why we ask that question at security or the speed? So, I mean, easy stuff, right? To do this, to follow these principles. And what is the thing there, why we don't do, is that we got something which is called technical debt in our systems. This concept of technical debt came from the DevOps, and actually it was presented before. But the idea is that if you do something and try to do a bit of the shortcuts and don't document and you know, not exactly properly, so you don't keep your system clean, then you can do this time and perhaps the next time, but the debts of the various technical juju's for your system, it starts somehow to grow and accumulate. And at one day, you really don't understand what's going on in your system, because system is getting more and more complex, and you start to lose control over that. And that makes hard to automate. You cannot really standardize, and to take and get rid of the technical debt may take years. DevOps community is saying that you need to dedicate some 20% of the cycles to that, keeping your systems clean and up to date. So it is really a lot. So if you think that you haven't done that for 5 years, then it takes another 1 year to catch up. So it's not so easy to do that, but I think this is something which really stops us. And examples. Most of you know, probably people coming from operations and infrastructure know the CMDB problem. So it's configuration management database. So there is a concept called ITIL, which has been quite popular in the past 20 years, and which tells us what is the best practice to do: change, release management, capacity management, and so on. And actually, it's laid a good foundation to operate in a proper way in IT infrastructure and operations. Now, the central concept there is configuration management database. You need to put every update there, make sure it always reflects what you have, all the components and all the links between the components. Easy. For first day. Next day, it's not anymore up to date. Next month is hopeless. And we try to do everything. We try to automate it, feed automatically. We try to do audits there. We try to federate and put a single database and multiple databases. Didn't work. So always you had to go to the system and see actually how it is done, and then you were kind of okay with that. So it wasn't really possible to do that. And one of the things why is the complexity of the systems. This is last year's Verizon report. What most striking for me from that report was that what they said that 78% of the intrusions, so successful attacks, took little or no special skills or resources. They were simple ones. And one thing is that we know that security people are not very good ones, obviously, that maybe this is a reason, but I'm not sure. I think they are good ones, but the problem is that we don't really control our system. We don't know where the open doors are. So just log in, because we may forget the accounts, the people who left, or there are some VMs, from somewhere, and we don't really control, and that shows this. And let me take another example. This is ISKE, which is probably for Estonian people very well known. And this is a baseline security process or model for Estonian public sector, based on the German version of baseline security. So this is a simplified process from the website, 7 steps, and you see first 3 of those are related somehow to mapping, to understanding what we have. So the security people do not go to CMDB, takes all the information and start to actually look what are the security classes, but they start to gather information because we don't have adequate information because the systems get so complex. Now, what my point is perhaps is that if you want to protect something, number one, you need to understand what it is, what you're trying to protect. If you know that your house has 4 doors and it actually has 14 doors, you might have a bit of problem. You might have as good locks as you want, but it is not enough. So understanding. And this understanding is not security people problem. This is IT people problem. This is development people problem, operations people problem. So it is not IT. So security is not about security people, so much at least. And it all starts from system design, defendable IT. If down there everything is okay, it is easier, much easier to protect. So system design, this is important. Now, what if the technical debt is something which stops us? So how really to get rid of that technical debt? Now, well, somebody has to pay. If I said that if you accumulated that technical debts and you have to pay it back, and finance people know that if you have some debt, then you have to usually pay it back with interest. And Frank pointed out yesterday that usually then, at the moment when you have to pay it back, the interest rate is flexible. So you may not know actually how much you have to pay back. Now, but the thing is that if you have to really clean up your system and make it nice and clean, then you have to take people, resources, money to make it. And it is not so easy when you have so many projects in your line. But somebody has to do that. And if the effort is pretty big and you need a lot of resources there, that probably does not come from the IT level, but also CEO has to be involved there, and CFO has to be involved. Say, okay, we need to fix our IT. We need to put more and do what we haven't done because we had all those deadlines, right? But how the management does decisions if they have to pay. The first one is, I know one of the CFOs who told that how he does the decisions. And he said that first he said no. Second time he will say as well, no. And if the person comes the third time, then he starts to think about it. But at first you try to say no to everything, not to pay, right? You only pay when you see it is absolutely necessary. How do you know that it is absolutely necessary? By experience, of course. And experience comes from the learning. And the question is now that is the top management in the learning cycle, that if something goes wrong in safety or security, do they understand that they had also their role in that situation? I'm not really sure of that because of this. The model we have accidents, in safety at least, is domino model. Started 100 years ago. And it helped a lot us, and it assumes that something goes wrong, which is, causes next thing go wrong, and the next thing goes wrong, so one stone is falling, and then others will fall. And if you look at this model, analyze the accident using this model. Who is the guilty one? The first guy who actually touched that first stone there. Clear. Root cause is there. It is so clear that we forget to ask that why the system was designed like that. So was it a bad design, or that was a cost pressure or productivity pressure? So we find actually the person who is guilty, and then we say that we retrain or fire, or we do something, get a new person, and then put more guidelines there. Don't touch that first stone, please. But we don't see what is around there. And the outcome of that is that management or the system designers, they don't get feedback, they don't learn, and that means that they don't pay because they don't take it really seriously. So we need somehow to get them also into the system, and we need perhaps a new model. And the model the complex systems. I wanted to tell one more story in Newhan. So our IT system, the market was complex. And what we see is that IT systems are also kind of a complex systems. I wanted to ask the question that what is the difference of those two numbers? Well, not big difference. But what that difference caused, it gave us butterfly effects. The Edward Lorenz, scientist, many years ago, 1961, ran an experiment. He had a big computer, and that's a very big computer, and ran simulation, a weather forecast simulation. Took hours, obviously. And he had to run many experiments there and many simulations there. At one time something goes wrong, and the process was stopped in the middle. And then thought, okay, I will not go back in the beginning and start everything from scratch again, but I will save time. I will input intermediate data from that middle point when it stopped, and continue my simulation. But he was lazy. He was lazy and didn't put all the number 05061227, but instead of that puts 506. The result was completely different. How it can happen that very small change can do a very big, cause very big effects. And started to think, and all the system theory and complex systems and non-linear systems all came there. So really they said that the flap of the butterfly can shade the weather in the world. And IT systems are also complex, and that's why we need the different models to analyze that, which are not so simple. And we know that IT systems are the complex, because what we say that don't fix if it ain't broke. So we may try to do it a little better, but it's not a good idea because we don't know how it actually ends, because we don't understand actually, because they are really complex systems, right? And for complex systems, we need the different models, how to analyze them, and how to see that all the people who should be in the loop are there in the learning loop. And I refer to the Nancy G. Leveson from MIT, and they developed a new model of causality for the safety. They had a similar, and this domino effect is also from his book, actually, her book. And she's saying that if you take just that probabilistic methods of understanding from where the trouble can come, then you do half of the job. Because again, very important actors like people, they are kind of out of that loop. And it doesn't allow you to learn and in complex systems where all the people are in. And she's saying that in traditional view, the operator is guilty. The pilot is guilty, and nuclear power reactor, all this kind of the operator is guilty. And the thinking started from the 50s, 60s, from US, and they had a funny situation. They had aircraft catastrophe in military. And guess who was guilty? The pilot. They did something wrong against the regulation or something like that. Then they started to do missiles, ballistic missiles, and research and test the missiles. And they crashed as well. And then it was hard to tell that pilot was guilty. So something else was wrong. And then they gradually understood that it is not so much about the pilots or the operators, about the system design, which need to be really fixed. So what they tell to us, this concept, this theory tells that it is not about pilots or operators. It's about requirements It's about system design. So the error there is rather a symptom, not the cause. So the red button, don't touch here because then wings of the plane will fall off. Well, it is not a good idea to do that, right? But we kind of have those situations in our IT. Right, and it's not only a kind of approach that you should do in this way, but they have also developed a model how to use and how to show that what are the causes in the complex environment of the accidents, or perhaps also for the security. So they called it STAMP, System Theoretic Analysis Accident Model and Process, which is top-down model. Usually in security and safety, we use fault trees, which is bottom-up models. We look at specific, thing, what goes wrong, and see what happens then. But this is top-down model. It's a different view, focused on control and constraints, and comes to the requirements and to the design. Well, it tells that we cannot understand all the states of the systems, but we need to understand those which are dangerous, and make sure that those states are put into the requirements that cannot happen. And if you got those requirements in your requirements from the first day, all the engineers, developers, operators, they can actually use them when they build the system. So the safety comes built into the system, not anyone bolts on later, right? So this different approach, and it was developed for safety, and they have run a number of cases in military and other fields and applied that very, very successful in safety. But they also think that it's possible to apply that to security, that new model. And what they say is basically that the difference between the security and the safety is that in safety something goes wrong, but in security somebody helps to get it wrong. But the cause is kind of similar. You can avoid those things by very good system design. And they say basically that you don't really look how to avoid threats, but how to control vulnerabilities. So it's kind of immune system. We have bad diseases around us and all the bad, viruses around us, but we are strong. We are here in this room because the immune system actually somehow works for us, right? And how we can use this kind of concept also in our systems. Why they have not applied that to security yet. They are in process. They have research in MIT right now and should be ready by summer. But they are brave enough in the articles to take a Stuxnet example. I said it was Rolls-Royce of the malware, invisible. You can't get it. You can't feel it before it starts to act. So they say that actually that was engineering error. That if the system had a requirement there that the centrifuge must never work above the speed, spin above the speed of the maximum, the malware couldn't do much about that. Well, security people will tell that then malware had, found something else to do. Of course, fine. But they are brave enough to take that example. And that's kind of interesting, probably also for security people, how to use this kind of model, causality, from that book I showed, which is actually freely available from Nancy's websites, and how to use that. By the way, the Chaos Monkey is an example of that. You have a requirement, system must be up and running, even if the service goes down. And system is designed according to that requirement. So it is about defendable IT. When security people come to the production system and try to make it secure, it is a bit too late. The foundation is good design. And when I touched before and talked about speed and security, I think that the speed and security are the branches of the same tree, and it starts from the good design. If you've got a good design, good operations, you can actually do both. But the system thinking, system design, they are absolutely important. That's why we have 15 security people here, and we have half development, half of the operations people. Because it's not anymore security's team business. It's our all. We need all to work together to make it happen. So how? I just gave a couple of hints, and I'm not sure are they, is it right way or wrong way? But that's why we have conference in this format to discuss what could be the new ways to solve and get out from that zero-sum game what we have with the bad guys right now. So coming back then and ask that as any company bankrupted because of cyber attack, maybe even if nobody has really been killed because of cyber attack, then I would look again and take the example from the animal kingdom. Not all the animals are die because they are ill or sick, but they are ill. When they are ill, they are weak and they are getting eaten by somebody. When the security is not good, when the speed is not good, that probably is not the single root cause of the death of the company. But in that complex environment, it definitely contributes. So I guess that actually there are more companies than we think. And to finish, to say then why we have this title to answer to that question is that I think what cyber criminals teach to us, it's not that they are very good, but it is like mirror in front of us. Their success tells something about our systems, our organizations, our system design. We need somehow to focus to make sure that we understand our systems well, protect them well, and that helps to be, competitive and secure. So the last quote from Art of War, there's nothing new in the world, right? If you know neither the enemy nor yourself, you will always win. There is no chance. We have a bit of problem of knowing ourselves. We need to fix that to find how to really create that defendable, understandable IT. And then we have 50-50 chance, and then we have to actually ask the cyber criminals to come and talk, and then we're going to win. So thank you very much for your attention. I wish you a very thought-provoking conference, and let's see, can we solve in the next 8 hours all the security question, or there are some few questions what we're going to do it in next year. So thank you very much.